Hello coffee roasters, Neil Wilson here, and today I want to show you a project I've been working on recently called CRUCS. That's been available for several months now, and while I've been adding more to it, this started as a project to take a tool that I've been using in my own shop for the past several years for creating roasting plans, and putting a nicer interface around that to make it easier for myself to use, but also to get this to a state where people outside of my company can use it. I'll be making a few videos covering different ways of using this, especially as more features are added in future releases, but for this one I'll be showing you how to design a new roasting plan from scratch and some of the tricks that I use for adjusting the curves this generates. Designing realistic, easy-to-follow plans for what you're going to do at the coffee roaster is a skill that really helps you get more out of profile coffee roasting because it forces you to be explicit in what it is that you're really trying to accomplish at the machine, and it makes it easier to think about roasting in terms of how changes to the roast profile impact finished product characteristics. If you can reason about what it is that you're trying to do and design a plan that you think will do that, then when you take that plan to the roasting machine, following that plan is the same as your day-to-day production roasting. Once you've successfully matched a batch to your plan, you can taste that and know the differences you're noticing are there because of intentional roasting decisions. To make this as broadly useful as I could, I decided to make this as a single-file web page that works in reasonably up-to-date versions of any of the major browsers on Mac, Windows, Linux, Android, iOS, probably other systems I haven't tested as well. So just point your browser to crux.net. There's no account to set up or sign into, so we can just get on with designing our example roasting plan. First, I'm going to click on this Data tab at the top. That gives us some controls for entering our control points, and I'll start with this Insert Point section to specify a point on the curve in the roasting plan. If I'm starting completely from scratch, I might decide to ignore turnaround. While the probes in a heated roasting chamber are hot and will cool down when coming into contact with the coffee itself is starting at about the temperature of the room it's stored in. Let's say that at time 0, the coffee is a comfortable 70 degrees Fahrenheit, and we can see that we now have a line in the control points section, but with only one point, we don't have anything on the graph yet. CRUCS does default to Fahrenheit, but the underlying math doesn't care about the units at all, and if you wanted to work in Celsius, you could go to the Display tab to change the unit and adjust the temperature and rate axis settings to something more appropriate for that unit. You can also change the horizontal axis settings. That defaults to 20 minutes, but there are a lot of machines that can roast even very dark roasts faster than that, and there are roasting companies that don't go dark enough to ever need such a long batch, so you can shorten that if you want, or if you're roasting on something much less efficient and need longer batches, you can extend that as well. Anything that you change here gets saved in your web browser's local storage, so you only need to set things up the way you like once, and those settings will still be applied the next time you use CRUCS. For our next data point, I like to have something close to where we expect an early maximum rate of change after coming out of turnaround. This is where I like to think of as our probe readings are close enough to reality and we're far enough in to have a good sense of how we're doing with replicating the plan. So if our turnaround is at 1.5 minutes, we'll go out another 1.5 minutes, and let's say we want to be at 200 degrees Fahrenheit by 3 minutes. The time field here is a little bit unconventional, but in a way that you can make the kind of data entry we're doing here a little faster, a little easier. If there's no colon, then this will be interpreted as a number of seconds, so you could type 180, and that would work. If there is a colon, everything before the colon gets interpreted as minutes, and everything after the colon is interpreted as seconds. But if we have an even number of minutes, we can just type in, for example, 3 colon, and the empty space after the colon will be interpreted as 0 seconds. Then tab over to temperature, put in 200, tab over to insert, and I can just hit space to activate the button. That then moves the focus back to the time field, so I can put in the next control point. Of course, if you want to mouse around, or if you're using a computer that has a touch screen, you can use those, click, tap, whatever you're comfortable with is fine. Now we see a couple lines in the graph, one representing our bean temperature, the other the rate of change, which, since all we have is a straight line, the rate is constant, but let's be realistic. The coffee isn't going to respond like that. So I'm going to put in a third point so that we have the start of a curve. And for this, I'm going to put in a time of -1 and repeat our initial temperature of 70 degrees. That forces the slope of the curve at the start to a rate closer to 0, and that looks a lot better. Moving on, I might say that I want to reach our color change from green to yellow in, say, 6.5 minutes. So we could type this in as 6 colon 30. We could also type it in as 6.5 colon, and that will be interpreted in the same way. And on my roasting machine, I have this color change event consistently at a temperature of 300 degrees. And we already see that the rate of change is starting to look a little bit more like what you'd expect at the start of a roast, just with a much faster ascent at the start, because we're not hiding that with turnaround. I have the rate of change set to Fahrenheit degrees per 30 seconds, but this is another thing that can be changed in the display tab. So if you prefer degrees per minute or degrees per second, you can change the denominator value. And there are other settings that change how this is calculated. If you're using other software for recording roasting data, you can adjust these settings to make the rate of change calculation in CRUCS closer to what your logging software does. These other settings are less important for a synthetic roasting plan like we're creating in this video, but becomes more useful if you're importing data from an automated logging system. The next point that I tend to be interested in is where the coffee has changed from yellow to brown in color. The duration where the color of the coffee is yellow tends to connect to the perceived intensity of sweetness in the coffee, and is where you can control how deeply into caramel flavors you want to go. I like 100 seconds as a good starting point, but that's just a matter of my personal preference, and for your coffees and for what you want to bring out of them, you might find a faster or slower progression here works better for you. If you're following along at home, do feel free to change things up and put in numbers that you like better. So for time, we could recognize that 100 seconds is 1 minute and 40 seconds and count from our 6:30 start of yellow, add a minute to get 7:30, half a minute to 8, and our last 10 seconds to 8:10. Or we could say 6.5 colon 100, and that will be interpreted as 6.5 minutes plus 100 seconds, which normalizes to the same thing. That's a little more typing, but a little less thinking. The temperature that we want here is 330 degrees for the machines that I use. Next, let's get in a measurement for first crack. And let's say we want to get there in 11 minutes. On my machine, this is happening consistently at 380 degrees. Finally, let's say we want to finish up at 1430 and let's say 410 degrees. On my machine, second crack starts at 430, so we're stopping 20 degrees prior to that. Now you can really see some curviness happening in the rate, but it's a smooth, gentle curve where we're leveling out a bit as we get into the part of the roast with significant tasteable chemistry, picking up the pace a bit as the coffee changes from yellow to brown, and then anticipating first crack with a significant rate reduction that will just ride to the end. We could stick to that plan, and what we'd expect to see is we'd have our live data coming in higher than the plan through turnaround, but as we come out of turnaround, we'd start to line up with the plan and continue on trying to match what we're doing from around where we hit our maximum rate of change. Once the batch data is coming in and aligned with the plan, following along for the rest of this is very easy, and if you get the results in the cup that you wanted, you'd just save a recording of that batch as your plan for future batches, so you have something that you can match throughout the whole roast. Alternately, we can try to model turnaround. So let's do that just to show that you can. First, I'm going to hit the delete button in the control point section next to our first two measurements at -1 and 0. And you can see that as those points are deleted, the values go up into the insert point section. So if you delete something you didn't want to, you can just press insert, and it goes back. You'll also notice that even though we no longer have a control point for time 0, the graph extrapolates back along a straight line, so you don't strictly need to start at 0. But for this example, I'll just go ahead and edit the temperature up to, let's say, 340. What that number should be and the other control points coming up around turnaround will depend on the specifics of your machine, what your typical batch size is compared with machine capacity, and what kind of preheat or between batch protocol you use. So feel free to adjust any of this to closer match what you tend to find on your machine. Then we need our minimum at 1.5 minutes, and let's call that 165. And you can see that this doesn't quite get the minimum where we want it, so I'm going to put in a couple more points. Let's say that 10 seconds earlier the temperature is reading 2 degrees higher, so 120 for time, 167 for temperature. That gets things a lot closer, but I do like to have values on both sides, so I'll put in one more point 1 degree higher than minimum 10 seconds later, or 140 and 166. To the left of turnaround still looks a little unnatural to me. In practice, I'd probably leave that since we're in the part of the roast where deviation from the plan doesn't matter, and we don't have a huge amount of control even if it did. But for the purpose of the demo, let's put in one more control point. 30 seconds, and I'm just going to eyeball this as 225 degrees. And that's looking pretty good to me. That gives us a steeper decline at the start of the roast. You can see that the maximum rate has come down and has a bit of a plateau before we get into a decline in preparation for color change. That's very normal for me to see on my roaster, so we could once again call it done. We've got a plan that progresses through various significant ranges in durations we've picked out to a determined endpoint, and this is a plan that I can follow on my roaster. If you're thinking about what to do at the roaster in terms of a small number of key events, things that happen at consistent temperature that we can use our eyes and ears to pick out, the curves that CRUCS generates from these points tend to be very easy to follow, assuming that the times for those events and durations defined between them are realistic for the roasting machine you're using and the batch size you need to run. If you're well practiced with your machine, you should be able to make only a very small number of control changes to keep the coffee following the plan. But sometimes what you get isn't quite what you wanted. So I want to show some different approaches to reshaping the curve to get what you want. If you're new to roast planning, I'd recommend not getting too hung up on the shape you're seeing and what you may have been told is what that should look like, instead focusing on what you're tasting in the cup and how changes to these range durations, stretching them out or pushing through those faster, and how the coffee changes when you roast that lighter or darker. These kinds of changes are all going to be far more significant than any curve reshaping that keeps the end point in the same place and keeps the ranges where we have different kinds of tasteable chemistry the same. We'll also be using a little more math for the rest of this section, so if you want to skip ahead a little bit, now is a good time to do that. Some people might not like the dip and bounce that we have right around color change from yellow to brown. There are a few ways we can deal with this. For this kind of cleanup, you can often get a good result just by deleting a control point. And there are 3 options that work here. But it's important to note that when you're deleting a control point at the boundary between 2 of our ranges, we're very likely to change the duration of both of those ranges. The first choice we have is our color change from green to yellow. This is often a good choice because prior to color change, there isn't known tasteable chemistry happening in the coffee, and the change is going to be quite small. So while there are physical changes happening as soon as the coffee gets into the machine, the very slight physical differences aren't going to cause problems for controlling the roast or have an impact on later chemical changes. So only one of the ranges we're changing is contributing to a tasteable effect. So now we can see that we're reaching 300 degrees around 6 minutes 46, 6:47 instead of 6.5 minutes, which means that the coffee is staying green for 16 or 17 more seconds, and instead we're going through the range where the coffee is yellow in 16 or 17 fewer seconds. So that's 123, 124 instead of 140. And you might be fine with that change. My production roaster tends to be a little more sluggish at the start of the roast, so this would be a little easier for me to follow. Our next option would be this 810 point where we have the color change from yellow to brown. Removing that is going to change the duration of both the range where the coffee is yellow and the remainder of the time prior to first crack. And we can see that now we're hitting 330 degrees at 7 minutes 51 seconds instead of 8 minutes 10 seconds. So that's a 19-second difference where we're spending 121 while the coffee is yellow, and we're stretching out the time while the coffee is brown prior to first crack. Instead of 250, that's now a 309 range. Finally, we could also remove this 11-minute control point marking the start of first crack. That's going to leave the time while the coffee is yellow the same, but change the durations while the coffee is brown prior to first crack and the duration between first crack and the end of the batch. This is pushing the start of first crack out to 11:52, so that's 52 seconds longer prior to the start of first crack, and 52 seconds less time between the start of first crack and the end of the batch. As you'd expect, this also has the rate of change at the roast quite a bit higher than what we've seen in earlier options. Which of these you might want to go with really should depend on the sensory results you want to achieve, as the changes to different parts of the roast will affect different flavor attributes, even though we're keeping the total roasting time the same and getting out to the same end temperature. But let's say that we picked the durations for these ranges where tasteable chemistry is happening for a reason, and we really do want to keep 1 minute 40 in yellow, 2 minutes 50 in brown, 3 minutes 30 past first crack. Now we're really getting into things that are going to have very little impact on the character of the finished product, but some of these changes might result in a plan that's easier to follow, and there's some value in that. If we go down to the table, we can see that we're going into our yellow range at a rate of 11.3 degrees per 30 seconds, which, considering that to go through 30 degrees in 100 seconds means that you're averaging 9 degrees per 30 seconds, seems a little fast. So my first thought is to slow down the start of the roast a bit. As mentioned earlier, you can make some pretty big changes to the duration of this first range prior to color change without getting a tasteable impact on the coffee. So this is something that you can set to whatever is going to make it easiest to stay on track in the later, more significant parts of the roast. We only have 4 points in right now from start of yellow through the end. So let's try deleting each of those in turn, adding 30 seconds of time to each one, and reinserting the edited point. So 6:30 becomes 7 minutes. 8:10 becomes 8:40. 11 minutes becomes 11:30. And 14:30 becomes 15 minutes. And now we can see that we're coming into the range at 9.9 degrees per 30 seconds. So that's a lot closer to the average rate we want for the range. And this already looks a lot better. And once again, this is something that I personally would be inclined to keep as is, rather than getting too hung up on a minor bump. But we certainly can still smooth that out by adding a couple more points to further constrain the rate of change at the ends of a range, similar to what we did to get turnaround at the time we wanted. Looking at this, the first thing I'd try is clamping down around first crack. So let's say that we want to come into first crack at close to the average rate of change we want in our brown range. To calculate that, we'd take the 50 degrees the range spans and divide that by the 2 minutes 50 seconds. That's easier if we do it in seconds, so really divide 50 by 170, and I'll put this clamping point 5 seconds away from the end of the range, so multiply the result by 5. And this doesn't work out exactly, but it rounds to 1.47. You can put these kinds of clamping points either inside or outside of the range we're trying to constrain. It doesn't matter much, but I prefer putting them inside the range. So we'd add a point at 11:25. That's 5 seconds prior to the start of first crack. And 380 minus 1.47 is 378.53. That's not quite perfect. We have this local minimum rate in the neighborhood of 9 minutes, and the rate creeps up a couple tenths of a degree per 30 seconds as we approach first crack. And at this point, it's fair to ask if your data logging hardware is even good enough that you can tell that that's happening. It might be, but the answer to that question is no on a lot of the installations I've seen. Still, we can tweak the other side of this plateau by doing the same thing around the color change from green to yellow. We've already established that this yellow range averages 9 degrees per 30 seconds. That's equivalent to 1.5 degrees per 5 seconds. And once again, we'll put that on the interior of the range. And that's 705 and 301.5. And we can see that our rate is back to strictly non-ascending. There have been several places along the way where we could have decided to say that we have a plan that we like, and wherever we decide to stop, the next step is to take the plan to the coffee roaster and successfully follow that plan. There are a couple ways we can do that. Well, I did write Typica, and that's what I use for my own shop. I think this kind of profile design capability should be useful regardless of what you're using for roast logging, and that includes going back to pen and paper. We can go to File, Print, and we can see in our print preview a table and a graph. There's a nice big empty space at the top, so you can slide this into a clipboard without covering up anything important. The lines in the table extend out so you can write in your own measurements for 1 or 2 batches roasted against the plan, and there's plenty of space for any other notes you might want to put in. So that might be inventory control data or tasting notes. Whatever you want to use that space for is fine. If you don't like the bean and rate headers, you can change those in the Layers tab. And here you can also change the color of those data series in the graph, turn off rate of change if you don't like it. There's some other stuff here that I'll get to in a future video. If you do have logging software, you can go to the Export tab. Here there are currently a couple choices for what data format you want to export. CSV will get you something that you can open in any spreadsheet application, and there are other programs that can import CSV. I might need to put some additional options here in a future version to improve the interop story, so this is something where if you're not using Typica, and it would be better to have, say, an option for a different time format that something else might expect, I'd certainly welcome feature requests based on real needs. If you are using Typica, then it's better to use the Typica XML export section. In either case, you put in whatever file name you want and click the button. The other thing you might use this for is if you might want to open this plan up in CRUCS again, I'd recommend exporting in Typica XML format, as CRUCS saves a little extra data that Typica currently ignores, but it preserves all of your control points so that if you went to the Import tab and use the Import Typica XML section to open that, you'll have all of the same control points you specified at the time of export. I'm not opposed to adding additional import and export options for other programs in the future, but it would need to be an openly documented file format, as I don't have the time to reverse engineer that stuff or dig through code other people wrote to do that. Alternately, you can ask whoever wrote your preferred logging software to add a Typica XML import option. It's a pretty simple human-readable format that's easy to code for, or just look into using Typica instead. Heading back to the Data tab, I haven't mentioned this Set End Time section. This is really useful if you want to stop a batch earlier or later without changing the shape of the curve. So for example, let's say we wanted to try ending the batch at 400 degrees instead of 410. We can mouse over the graph and see that we're hitting 400 at 1309. So we put that in, hit set, and the shape of the curve remains completely unchanged, but now everything past our end time isn't shown. This can come in handy if you're doing a progressive roasting exercise with a big group where you need more coffee than is practical to get from your trier. So you have to do multiple batches but want to minimize the differences aside from where you're ending the batch. So you can start with the darkest thing you want to do and export plans that move the end time earlier and earlier until you get to the lightest thing you want. Similarly, we might ask what happens if we extend the roast to 16 minutes. And now you can see that it's extrapolated out to our new end time. That's something that can come in handy at profile design time as well. If you want a short linear section at the end, you can have your last control point be a little before where you want to end and then extrapolate back out to your desired end time. If you want to go back to a plan defined entirely by the control points, just delete the text in the field and hit set again. That covers what I wanted to talk about in this video. We ended up with a dozen points defining that final curve, but there were several places we could have stopped instead defined by fewer points, and you've seen how the shape of the curve can be changed just by adding, removing, or editing these control points to get plans that can be easily followed on real roasting equipment. If you found this video useful or want to help support keeping CRUCS updated and available, going back to the About tab in CRUCS, there's a support link that you can use to throw however much money at me as you want. Between repairs from a neighbor's tree falling across my property and replacing a 26-year-old furnace that finally gave out, it's been a more expensive start of the year than I'd hoped. So financial contributions are always appreciated, and there's an optional place to leave a message. You can resize that field if you want, and that's a great place to put in feature requests, bug reports, or just general encouragement. I hope this helps you in designing a more intentional plan to follow the next time you're looking to change how you're roasting a coffee. Thanks for watching.